Again, I've shortened this a little bit, but the crucial parts are, for number 9, we have an alpine trail mix, which is 40% nuts. We're going to call this X. We have a meadows trade mix that is 25% nuts. We're going to call that our Y. And what we want to do is to make a 10-pound batch that is 32% nuts. So how much of each? Again, this is a typical mixture problem. What do you suggest we do first? Well, we know that our alpine, which is X, plus our meadow, which is Y, we want to make 10 pounds. So that's the mixture we want to end up with. And then it's just like the previous one. The alpine is 40%, and we don't have to put decimals if we don't want to. And the meadows is 25%. And we're going to end up with a 32% of 10 pounds. So it's very much like the previous example for a mixture. We have a certain number of pounds of alpine, that is 40%. Certain number, it's going to be 10 pounds altogether, so that's one equation. And our other equation is 40% nuts, 25% nuts, 32% of 10 pounds. And that's our equation. And we're going to use substitution. All of these work out very well. Let me see, it's going to be 10 minus 1. There we go. Now, could you have used the other letter? Absolutely. But you remember, you have to define which mixture you're dealing with. And you do so by putting the 40% with the X, 25% with the Y. And then the algebra takes over. And this interesting, when it comes out, this X is going to be 4.6 pounds, and the Y is 5.3. And this is like 4 2/3, and this is like 5 1/3. So this is going to come out a little challenging. You're going to get some decimals here. And that will be a challenge, but that's how you solve it. In example 10, we're finally getting to this formula here, where it's interest equals principal times the rate times the time. And we'll show you what that is as we go on here. Now here, Whitney, who is a student, has taken out loans, a student loan for $14,000. Now, one loan is at 5% rate. And the other is at 7%. This is the rate. Now the interest, which is the accumulation of this on her principal, this is the principal here, after 1 year is $850. So we're wondering how much of this $14,000 is in each of these loans. You might say, why did you take it all at 5%? Well, then we wouldn't have a problem. Okay, So again, how do we do it? And again, this is sort of a mixture problem. So what do we know? Well, we're going to call the 5% x and the 7% y. So that gives us our first equation, that x plus y equals 14,000. So this is the amount she has with the interest of 5%, and this is the amount she has at 7%. And this is the total amount of principal. So in a sense, this is part of the principal, this is the total principal. So we're going to use this formula, principal, which in this case is x, and the rate is 5%. And we could have put just 5%, but I'll show you how to work that later. Plus 7% is the other rate of y. So this is rate times principal, and time is 1 year, so we don't have to put the 1 in there. So this is the interest at 5% of that portion of the loan, 7% at that portion of the loan, and the total interest now is 850. But since we have decimal places here, we have to put our decimal places there as well. Because I think the first thing you want to do is to get rid of all our decimals. Now I put them in decimal form because I had to do this. Because if you just said 5x and 7y is 850, that is incorrect. So now that you've eliminated all the decimals, it's easier to work. You're going to solve by substitution. And this will be x equals 14,000 minus y. And we've done those before. And when you work it all through and you get the answer, the 5% is going to be 6,500. And at the 7%, it's 7,500. And these add up to 14,000. Keep in mind, you can go to the tutors, you can go to Learning Center to get help if you need help in working the equations. Here, we're trying to feature how to go from word problems into your two equations where we're looking for a point of intersection. And this is where they intersect. X is this, y is that. Again, this is a typical mixture problem. Here we're mixing tropical punch, that is 18% fruit juice, with Caribbean punch, which is 24% fruit juice. And we want to make 18 liters of 20% juice. So notice the 20% is sort of in the middle. This is more concentrated. This is less concentrated. We're going to need some of each to get something in the middle. Now you could try this, but the algebra is what works easily for this. So we're going to call the tropical punch, the 18%, the X, the Caribbean punch, the Y, and we want to make 18. So X plus Y equals 18. Now let me give you a moment and see if you can, or you can pause the tape if you can get the second equation. And there it is. So again, 18% of the x, 24% of the y is 20% of 18. Now had I put decimals here, I would just multiply through to end up with that. And here you're going to use, I think, substitution. And let me give you the answers. For this, it's going to be 12 liters. And for this one, 6 liters. And that adds up to 18, and that mixture is 20%. Now we're getting to the distance formula, where, and this is very typical also, we have a van that's a truck that runs slower than a car. Well, the speed of the van is 50 miles per hour, and it's traveling a certain amount of time. Do we know that time? No. But we'll call that time t. Now a car gets on the highway, the same highway as the van, but it travels at 70 miles per hour. But it's leaving 1 hour later than the van. So its time is going to be t minus 1. That is, its time here less 1 hour. So this is the time for the car. Now, to sort of understand this, we have a van leaving, and then a car leaving, and we're looking for where the distance they travel is the same. So we look now at the distance formula. Distance is rate times time. So in a sense here, we have distance and distance are the same. What's different is rate times time. Rate times time. That would be rate 1, this is rate 2. Time 1, time 2. But we know that distance equals distance. So our formula for this could be rate times time equals rate times time. Because we know that these distances are the same. So this is going to equal that. So this is our formula here. And we can pick it right out of our chart. So the van is going to go 50 miles an hour for t amount of time. Does that make sense? Because there's the time, we don't know that time. We know this rate. So rate times time is distance. This stands for a certain amount of distance. And that's going to equal the car that is traveling at 70 miles per hour and doing this distance, or this time I should say. I have to put it in parentheses because this represents this distance and this distance is the same as this distance. So there's our equation. So how do we solve it? Well, we clear our parentheses. So we go 50t equals 70t minus 70. Now, to make it easier, I'm going to transpose the 70t over to this side. And that's going to give us a negative 20t equals a negative 70. So I'm transposing the 70 to this side. It becomes a negative 70 plus 50t gives me a negative 20t. Now I'm going to divide both sides by negative 20. And this gives me a positive. Notice this negative divided by a negative, and I can just cancel these out. I get time is 7/2. But what is 7/2? That's 3.5 hours. Now notice they said at what distance, or let me just check that here. Yeah, it's not when, but at what distance does the car catch up to the van? It's going to catch up in 3.5 hours, but how many miles is that? Well, we have to go 3.5 times 50, and that's going to be 175 miles. So this question had a little twist to it. They didn't want to know when, even though I put that there. Where, let's put here, where. And then at what mileage. Does the car catch up to the van? And it catches up at 175 miles. So we found out what t was, but t is not the answer. They want to know distance. So I multiply 3.5 times 50. And 3 times 50 is 150, and half of 50 is 25. Yeah, that makes sense. Okay? And I believe that's going to be the last problem I'm working for you on this. By the way, by knowing these on your test, you're not going to get anything more difficult than what we've presented here.